Hello again, everybody. This is Chuck Bowen, the editor and associate publisher at Lawn and Landscape Magazine. Again, I want to thank you for taking the time to attend today's webinar, An IPM Approach to Mosquito Control. With all of the news of the Zika virus and other mosquito-borne diseases that we all see around the country, I know this is a very important topic to folks in the landscape, lawn care, and structural pest control worlds. In fact, this is the largest webinar we've ever hosted. We have about 1,300 people registered. So it's clearly something that that will be very helpful, I think, to everybody on the presentation today. We've got two very smart presenters here for you today. Before we get into their sessions, though, I want to just go over a couple of housekeeping items. First is today's presentation is being recorded. So next week after the presentations, you will receive an email with a link to the slides from both Dr. Brown and Dr. Gallagher, as well as a link to the video recording. So you can share that with your team or watch it again. We will also be taking questions during the presentations. If you look on the right-hand side of your screen, there is a little widget there that says questions. If you type your questions in there, they'll come right to me, and we've set aside some time for questions and answers at the end of today's presentations. So lastly, I want to thank Syngenta for sponsoring today's presentation. Without their support, we wouldn't be able to bring this kind of education to you. So I think with that, we will get into the presentations. Our first presenter today is Dr. Grayson Brown, Professor of Entomology and Director of the Public Health Entomology Laboratory at the University of Kentucky in Lexington. His work focuses on improving management of arthropod vectors of human diseases such as ticks, sandflies, and mosquitoes. His group works closely with public health agencies at the federal, state, and local levels, primarily on mosquito management. His group was a pioneer in the development of several mosquito management techniques and products. They are especially well known for their continuing research on backyard mosquito control. Dr. Brown also works extensively with current international projects in several South American countries and some locations in Africa. He has published more than 100 scientific papers, acquired more than $5 million in research grants, and is former president of the Entomological Society of America, the largest entomological society in the world. With that, we will begin the first half of today's presentations with Dr. Brown, and the second half will be Dr. Nikki Gallagher from Syngenta speaking about effective mosquito control strategies. So for the first half, we'll hand things over to Dr. Brown.
Thank you so much, Chuck, and I appreciate all the work that you've done and Syngenta and having me here. It's a great honor to be able to speak in front of such a great audience. I'm going to be talking today about barrier applications for mosquito suppression in the suburban landscape. I'm going to be talking specifically about this component of the overall integrated pest management program for mosquitoes. But towards the end, I'm going to try to link this up with a more comprehensive management program. But I'm really going to be focusing on the use of barrier applications in the spatial scale of typical suburban backyards using primarily long residual synthetic pyrethroids. Now, mosquitoes are among the top concern among Americans. This is the result of an NPMA survey that was conducted a couple of years ago, reported in PCT Online. And when people were asked what insects were the top concerns that they had, 62%, by far the largest group, said mosquitoes. And this was before the Zika outbreak, and in fact, it was just at the beginning of the chikungunya outbreak. People were mostly hearing about dengue at this point. So since this came out, we've had two other large pandemics that have started up due to mosquitoes. When people are concerned about mosquitoes or asked what are the things that they were concerned about, the number one thing was diseases. Now, this is surveys of people here in North America where mosquito disease is not that big of a concern, really not that big of a risk, but still a large majority of the people polled said that was the principal concern that they had. So of the bugs Mosquitoes are the number one thing that they're concerned about, and they're mostly concerned about those bugs because of disease. Now, one of the reasons for this is because of the large amount of press that mosquito-borne outbreaks have recently been getting. When we look at the large-scale outbreaks in the Americas, we've had the West Nile virus that started up now about 15, 20 years ago, raged through the U.S., crossed the entire continent in 3 years. We were powerless to stop it. It's killed a couple of thousand people. It's died down because of some herd immunity, but it's still with us. Then shortly after that, the great dengue outbreak began. Millions of people in the Americas were infected, over 3 million in Brazil alone just in 1 year, 40,000 in just one city, Rio de Janeiro, which isn't even their biggest city. So it's been a horrible plague on the Latin American countries in particular. Chikungunya this time last year was raging. It's brought several Caribbean islands to their knees economically and has been a very serious, debilitating disease for many people, taking some people out, unable to work for months at a time. And now, of course, we have Zika that's in the news. Zika is really just getting going. I'm going to talk a little bit about that in just a minute. But the important thing about this list of diseases is that we're not done. I mean, it's not going to end here. There's more to come. Yeah, Zika is not the end of things. We are probably facing a series of viruses, mosquito-borne viruses, that will have different symptomologies, cause different problems, and we're going to have to fight them for the next several decades to come. We're not done. We're not even halfway through them yet. There's a lot more to come. Point is that this is a long-term problem that we have to deal with. I want to concentrate a little bit on Zika because there's so much interest in that in the press right now. Zika has been known in Africa for, gosh, over 50 years, 60 years, but it was only about 10 years ago that it broke out of Africa and began moving across the Pacific. And you can see this track here that took it from Micronesia to Chile by 2015. And it first showed up in Brazil in April of 2015. So it hasn't been in the Americas for even 1 year yet. The problem with Zika is, on one hand, there's symptoms. It's a mild, actually a fairly mild flu-like symptoms. You have eye redness, joint aches and ankles. You have a mild rash that you see here. It's not that bad. It's self-limiting, gets over with 3 days in a week. In fact, a large percentage of people that get infected with Zika are asymptomatic. They don't even know that they have it. So it's not that bad of a virus for the majority of the people. It's really only a serious threat to one group of people, and that's these: the pregnant mother and the baby. The mothers are showing increased susceptibility to Guillain-Barré syndrome, which is an autoimmune syndrome, leaves them paralyzed, particularly in their legs. The babies are born with these unusually small heads. The head is a result of decreased brain size, so the brain doesn't develop completely. And as it's been shown recently, Zika virus has a tendency or preference to preferentially attack fetal brain cells. It kills about 30% of them and retards development for the majority of the remainder. So you end up with a very small brain. This goes on to cause a number of medical problems early on in childhood. Those problems get worse, and these children generally don't make it to adolescence. It is now appearing that this is just the most gross morphological manifestation of a series of central nervous system disorders that these kids are experiencing. So the problems are really bad. This shows you a graph of the microcephalic births in Brazil that have occurred since Zika first showed up in April. And you can see that from 2007, which is the earliest we have records of microcephaly, it was just 100 or 200 a year. And then once Zika came in, boom, it goes shooting up to the thousands. Now, I want to point out that these numbers here are calendar year numbers. So this Zika showed up in April. It's primarily a threat to women in their first trimester of pregnancy. So 2 trimesters later, 6 months later, October, is when the first microcephalic babies started showing up. So this number for 2015 is really just the number of microcephalic births from October, November, December. That's it. And then for 2016, these numbers are just as of a couple of weeks ago. So we are currently on track to go up close to 10,000 by the end of this year. So this problem is bad. It's 20-fold worse than they've ever seen, and it's getting worse. So
looks like Dr. Brown got disconnected, but he's dialing back in presently, folks. So just stand by. Sorry, folks. So while Dr. Brown gets dialed back in, I know we have we have Dr. Nikki Gallagher on the line as well, and she's down in Columbus, Ohio, and she works with Syngenta and has some information for everybody in the second half of today's presentation on effective control strategies for mosquitoes. And Dr. Gallagher, I know just presently we were discussing some of the topics for protecting crew members out in the field. And when you look at that, is there anything that you've seen that's effective or that would be good for our attendees to know about?
Sure. So I think when most of the technicians are out there in the field, they're wearing their PPE, and that in itself is going to probably make sure that they're very well covered. They're going to be wearing long sleeve shirt, long pants, a hat. Would probably be recommended as well, especially if they have very short hair. They're going to be wearing gloves. But for some areas that might be exposed, what they want to wear is an EPA-approved repellent. So something like DEET, picaridin. There's also some approved oil of lemon and eucalyptus that's had some good data to stand behind that as well. I think there's another one as well, IR 3535. So those are all ones that the EPA will approve, that they can wear for themselves to protect themselves, whether they're at work or just on their own time, and to also to recommend to their homeowners. And there's also different levels of concentration of those. So DEET, for instance, comes in 10% or lower, and that's what you want to recommend for children.
Okay.
And then there are higher ones, anywhere from, I think I've seen, 60% and higher, and some of those are a little extreme. So you want to make sure you check the label. When it gets to really high concentrations, those are the ones that you probably just want to put on your clothes, not on your skin.
Oh, I see.
Yeah, so like about 33% or so is quite effective. And it depends on how long you want that repellent to last. And if it's just mosquitoes, or if there's some that can also be effective on ticks, you just want to make sure you read the label for the specific needs that you're looking for.
Okay, great. Well, looks like we've got Dr. Brown back. So whatever you're doing right now, Dr. Brown, keep doing it.
Okay. I ditched the phone connection. Phone connection. I'm going just straight with the computer because it was. I don't know.
Sounds great. So let's roll back right into it.
All right. So anyway, there's extensive public concern at all levels in Brazil. This particular sign here says, "Never let the mosquito be born. Fight them every hour. Always fight them every hour." And it's these types of billboards. There's many kinds of them throughout Brazil right now, in every corner. Every phone, every radio station is blasting mosquito control messages. Every TV channel has mosquito control advertisements constantly. They're really making a major public effort down there because people are scared. I mean, it's really bad in that area. Now, okay, so So mosquitoes are causing a tremendous amount of problem with disease transmission. People are concerned about it, even in locations where mosquitoes haven't begun to transmit serious disease, like in North America. And so it's probably worthwhile taking a minute here to talk about how mosquitoes actually do transmit disease. First of all, a misconception by a lot of people is that mosquitoes are flying syringes. That is, that if a mosquito lands on a person who has, I don't know, a cold or some other virus, and if that mosquito bites that person and then flies off of that person and flies directly to you and bites you, then you'll get it. Well, it doesn't work that way. It doesn't work that way at all. In order for a pathogen to be transmitted by a mosquito, it has to infect the mosquito in a very specific way. The mosquito's got all of the other characteristics necessary to enable transmission, and then the pathogen has to have the ability to infect the person when it comes from a mosquito, and if it's going to be a primary vector, the pathogen has to be able to return to that mosquito. It doesn't always have that last step, but often. We can't do much about the first one here. It has to infect the mosquito in a specific way. There's a few things that can be done there, not much. We can't do much about the pathogen having a pathogenic cycle. So instead, most of our mosquito disease transmission interruption is targeted at this middle one, interfering with the biological behavior, ecological traits that enable that transmission. And this is the real business end of the mosquito. This is a close-up of the head sticking with the mouth part sticking into the skin here. You have mandibles and maxillae form this outer sheath, and then the stylets go into the skin, and they have tiny little sensors down here at the bottom that enable the mosquito to see or to sense when it's contacting a blood cell. So this labium slides back, the mandibles and stylets slide down, the stylets pierce the skin and probe until they pick up a capillary tube, and at that point, when that stylet enters the capillary tube, that's when the saliva begins to flow, injecting anticoagulants and vasodilators and other things that facilitate blood uptake, and that's when disease transmission occurs. Full blood meal is a half to a couple of microliters, very, very tiny amounts of blood. I'm going to show you a video of what it looks like when those stylets are under the skin. This is a stylet of an Anopheles gambia. That's the African malaria mosquito in the skin of a mouse. And you're going to see that they're really actually quite active. They move around sort of like a worm. So I'm going to start this right here. And this is the stylet inside the skin. It's probing around. It's looking for a capillary tube. And those sensors are trying to sense where that capillary tube is going to be. It's going to find it right about here. And it's at this point right here. I've stopped it. It's at this point right here that if there's disease transmission, it occurs. In this case, if the mouse is going to get malaria, it's got malaria at this precise moment. If that was a Aedes mosquito that was transmitting dengue or chikungunya or Zika, then the patient would be getting that right now. You can see this stylet just pretty much sucks all the blood out of that capillary tube and shuts off flow through that capillary tube until the mosquito gets filled up. So that's the way it works on the inside of the skin. Talk a little bit about the mosquito life cycle here. Larvae are wigglers, pupae are tumblers. They're really quite active for an insect pupa. But they both breathe atmospheric air. For most mosquitoes, there's some that don't need atmospheric air, but most of them do. That's why oil on the surface of the water works as a smothering agent. The eggs tend to be laid either on the surface of the water like Culex. Culex lays their eggs in a raft like this. Anopheles lays their eggs on the surface of the water as well with floats. The eggs are laid individually, and they sort of bob around on the surface of the water until they hatch. Aedes eggs are laid in the mud or the moist soil next to the water, and they rely on water to rise up to the egg. These eggs can be quite desiccation resistant, and can stay in the soil for, depending on the species, up to 5 years, waiting for water to cover them and to make them, give them the opportunity to hatch. The larvae mostly feed on algae and bacteria, other microorganisms. Only the females, the adult females, suck blood. And, of course, the males and females both feed on nectar and other plant juices. They need that nectar. It provides carbohydrate, and that's what they use to power their flight muscles. So that's a very important biological need that both males and females have. Life cycle, most of the mosquitoes really don't travel very far. They're not very good flyers. They don't want to get up into the air currents. If they do get up in the air currents, of course, they can be blown for miles and miles. But that's not their preferred mode of travel. They would prefer to stay pretty close to where they're born, because if they go flying around, there's all kinds of hazards out there. There's spider webs. There's other predaceous insects. There's flying things that will get them. There's windshields, car windshields. There's a lot of danger in flying around. So it's to the advantage of the mosquito to stay close to where it's born. And this is an important factor in suburban mosquito management, because most people who have mosquitoes breeding on their property are feeding mosquitoes on their property. Now, I would like to talk a little bit about mosquitoes in the North American suburban landscape. We've got about 150 species of mosquitoes in North America, about 3,000 species worldwide, so 150 isn't really that much. They're scattered out into 8 different genera. And every one of these things has their own biology, their own ecology, their own behavior. They react to different stimuli. They have different periods of activity. And it's a really diverse biological group. We think of the ones that are serious disease transmission threats, but that's really only 10, or not even 10, in North America. Maybe another 10 less serious threats, and that is they don't infect that many people. And then another 20 or so are nuisance pests. They bite you, but they don't really pose much of a disease transmission risk. So really only a relatively small number of species are causing all the problems. And most of the problems, and particularly in this area here, this group here, the serious disease transmission, most of those are in the genus Aedes or Culex. These are the 2 bad boys of the mosquito world right now, at least in North America. They differ in very important and fundamental ways that you should, if you're interested in doing backyard mosquito control, you really have to understand, because as it turns out, their biological differences makes it pretty easy to control Aedes, very difficult to control Culex. These are the 2 generic biologies that we have to deal with. I've got Aedes and Aqua Irritatus. That's because Aqua Irritatus is a very closely related genus to Aedes, and for our purposes, we can consider them the same. They transmit different diseases. Culex tends to feed on birds, whereas the Aedes attack mammals. These guys feed during the day. These guys feed late at night. The important thing is that the daytime resting sites for Aedes is generally less than 10 feet off the ground. They're in bushes. They mostly attack mammals that are down on the ground. These guys have their resting sites up in the trees. So when you go out to spray for mosquitoes, unless you're going to be spraying way up high in the trees, you're not going to be getting these guys with a residual pyrethroid. Now, that's for the backyard perimeter applications. For the municipal guys, the guys who go out and spray the ULVs, put the ULVs out in cities with the spray trucks and stuff, they have a completely different situation. They use a different AI. Sumethrin is the preferred or most commonly used active ingredient. The backyard perimeter, you see a lot of lambda-cyhalothrin, bifenthrin, deltamethrin being used. Also, but the thing about this that's important is that sumethrin is used so much worldwide that we're beginning to get a serious problem with resistance. These are all synthetic pyrethroids, and so there's concern that sumethrin resistance will cross over into resistance to one of these. So far, it hasn't happened to a really serious extent, but that's good for us because that means that we can see it coming and we can still do something about it. I'm going to talk about resistance management later on. One of the differences between municipal and backyard spraying is when they're applied. The municipal guys generally have to get out late at night or very early in the morning, like between midnight and 3 a.m. And because they don't want to be spraying, they don't want to be fogging when people are out in their backyard grilling and the kids are playing and mom's gardening and stuff. And as a result, they are putting their applications out during a period of time when the Aedes mosquitoes are not active. They're bedded down. They're hiding up underneath leaves and underneath inside crawl spaces and under eaves and places where they're protected. And so as a result of that, it's very common that municipal mosquito control efforts are relatively ineffective against Aedes mosquitoes and relatively effective against Culex mosquitoes. So that's good. So backyard perimeter sprays are really good against Aedes for a reason I'm going to explain here in a minute. And municipal control methods are really good against Culex. So together, we can get them both. We can get both of the bad guys. So that's an important linkage that we need to recognize. I'd like to talk a little bit about suburban backyard as a mosquito habitat. That is, what are the things that these two genera of mosquitoes need to have present in a backyard in order to really cause a problem. They need different types of water. Aedes likes cleaner water than does Culex. That means that in years where there's a lot of rain, then there's going to be a lot of clean water. There's going to be a lot of Aedes. In years where you have droughts, the water that's available is going to be stagnant, and so you're going to have a lot of Culex. And that's what we see. So during years where there's droughts, we have a lot of Culex-borne disease. Where there's rainy summers, we have a lot of Aedes-caused problems. So that's one of the major differences here. Yeah, that's the main thing. Otherwise, I've covered some of this stuff. Now, one of the things that's really important in understanding backyard mosquito control is how the mosquitoes move about in a backyard, what are their stimuli, and what are they reacting to. Mosquitoes have a pretty simple stimulus response. It's a sequence of things that they respond to, and it's worthwhile understanding what they are. First day or so, when they come out as an adult, they just kind of sit there, harden up their cuticle, get ready to fly. But then they begin to search for nectar. They need that hard carbohydrate source, so they start looking for flowers, really. Next, they'll start searching for a blood meal, the females will. By next, I mean within a day or so. If there's no olfactory stimuli, they'll move towards light source. Their preferred olfactory stimulus, though, is the CO2, and that's a long-distance stimulus. That brings them in from, dozens of yards away, certainly across the length of a backyard. But once they get close, they start zooming, they start keying in on other criteria, volatile chemicals for individuals, and body heat. So they will fly towards a heat source once they get close to CO2, or once they follow a CO2 plume. And then when they get into a group of people, the one person that they decide to bite is selected based on the volatile chemicals coming off of that individual's skin. After the blood meal, then they go look for an open position site, and then they're looking for volatiles that are emitted by the microfauna in the water, the bacteria and the algae that are actually in that water. That will tell them whether or not that water is suitable for their larvae. And after that, they go back up here to 3, and they repeat this. This cycle from 3 to 4 to 5 is what we call a gonotropic cycle. It starts with them powering their flight muscles. It ends with them delivering eggs, and then they start that up again. They'll go through 3, sometimes 4 of these in an adult lifetime. How do they move towards people? You look at this backyard here. You got Dad there with the kids, and you got the bushes. I mean, this is just mosquito heaven. You got the bushes here for the mosquitoes to hide in. You got blood meal right there. You've got plenty of flowers around for them to get nectar. You've got some water here, and looks like a little bit down here, probably in some of the potted plants. You got this rain bucket that's upside down collecting water. So this is really everything that you need if you're a mosquito right here in this one little spot. Let's say that Dad and the kids are sitting out here, and there's a very slight amount of air movement in this particular direction, going from right to left. So that's going to cause the volatiles and the CO2 CO2 plume to move from right to left. And let's say there's a mosquito sitting up here that starts picking up this CO2 plume, and she needs a blood meal. How does she get from here to here? Well, what she does not do is she does not just jump off of this leaf and fly over here and bite that. No, that's not the way they do it. Instead, what they do is they'll start from here. They're very skittish. They're afraid. They're pretty easily killed, and they know it. And so they'll fly down to get a little bit better into the CO2 plume, stop here on the bush, sniff around for a little bit, then hippie hop over here, go up the CO2 plume a little bit more, sniff around, go up a little bit more, sniff around. So they're hunting. This is hunting the way you would still hunt a deer. And when you get close enough, then they zoom in. But the point is that they will stop 3 or 4 times over this short of a distance before they get to their target. This is key. They're stopping, not just the fact that they're stopping, but the fact that they're stopping on this vegetation. So that's the basis of how the perimeter applications for mosquito control work. It's why treating the perimeter will prevent mosquitoes from coming from the neighbor's yard into your yard and bite you, because they have to go through that treated vegetation. So the objective then is to treat the mosquitoes, adult resting sites, and pass-through vegetation. And it's important to try to work away from a house. So if you take a look at this house here, we've got vegetation near the house, out here in the yard, and then on the perimeter. We want to start by treating the vegetation closest to the house and work our way out. So we start off by treating these bushes right here. They turn sort of red. Then we move further out into the yard, and we work in this sort of concentric circle, and we finally finish up by treating the perimeter. Now, why do you want to do it that way? Well, the reason is what you want to do is you want to push those mosquitoes completely out of the yard. Those that get contacted by the spray, of course, are going to be killed, but a lot of them won't. And by pushing them out of the yard, you do 2 things. Number one, you force the mosquitoes, if they want to reinvade that yard, to come back through that insecticide barrier that you've just established. And they will. They'll try to do that. That insecticide barrier will be really fresh then, and you'll kill them. The second thing that you do by doing that is that as soon as the homeowner comes home, the very first thing they do is they run out to the backyard and they stand there and see if the mosquito control effort had any effect at all. And they will be amazed by the fact that there aren't any mosquitoes. You just flushed them out a couple hours ago. So it's a very positive reinforcement for the homeowner. It accomplishes 2 things there. Get the mosquitoes out of the yard, forcing them coming back through the insecticide, and giving an initial positive impression on the part of the homeowner. So technique is important. Properties, as in the house properties, are important. And there's good things and there's bad things. And I wanted to talk a little bit about what the bad things are. Bad things are properties with little or no perimeter vegetation, that have a lot of flowers and vegetables, herb gardens. We don't want to spray those. It's a bad technique to treat in a haphazard pattern, and it's bad to fail to use proper PPE. Let me show you an example of bad stuff. That's this young lady. Let me turn the sound down here. This young lady is treating this property. It has no perimeter vegetation at all. She's walking around in a more or less haphazard pattern. She's spraying the grass. She has no PPE. So this is a technique that is bad in every possible way. Now, in this particular case, this is what she wants to do. She's a graduate student of mine. She's treating a house that's going to be one of our controls. The objective of this treatment is to look like you're doing something, but to not actually disturb the mosquitoes at all. So her objective is to have minimum impact on mosquitoes. So if you want to have the absolute minimum impact on mosquitoes, this is the way to do it. But if you're trying to have an impact on mosquito population, this is everything possible being done wrongly. So that's what bad looks like. This is what good looks like. You've got Charlie Asbury here from All Right Pest Control. He's got his nozzle sticking right into really thick vegetation. We're in a yard that is just covered with vegetation. This is a wonderful yard for mosquito control. single application on this yard will provide mosquito control pretty much the entire season. He's got good PPE. He's starting at the house, and he's going to work around the house. He's going to work in concentric circles away from the house and end up treating all of this vegetation. He's going to treat dense, non-flowering ground vegetation. Not going to treat the flower beds here. He's going to treat the non-flowering ground cover like this. Going to pay special attention to dense canopies getting up under here. Notice here that his nozzle is never getting above higher than his chin. That's very important to avoid chemical trespass. This is a general rule of thumb that we try to impress on our applicators. Don't get that nozzle up too high, because that's when you start having problems with drift and trespass. We get out in this perimeter area. We especially target on these thick overgrowth bushes. If you live in an area that has a lot of Japanese honeysuckle, you want to drench those things because they are mosquito magnets. They are really terrible for Aedes mosquitoes. Want to get up underneath decks, crawl spaces, raised structures like outbuildings. Mosquitoes will be hanging out there during the day and then returning there late in the evening. The objective is to treat any real location that is dark, cool, and moist. This is Quentin making a treatment around the houses. Now, what I selected this video for is not because of these sprays here, but it's important if you have a low-growing tree like this one right here to get out and try to spray at least a little bit of insecticide up on the undersides of the leaves. You won't be able to get all the way up to the top of that canopy, but you'll at least be able to get maybe in this case of a tree this size, at least about a third up. That's not going to kill all the culex, but it will have an impact on the number of mosquitoes that you get out of that tree, at least if you lift a trap up into that tree. So it's worthwhile treating the base of the trees or the underside of the leaves near the bottom of the tree canopy for that reason alone. Provides a little bit more protection for the homeowner. In this video, he's going along. I'm going to show you what we do here with the thicker bushes. But here we're treating some flower beds that where the flowering is stopped. So these daylilies are a good place to treat once the flowering is stopped. When you get through these bushes, you really want to get that nozzle right down into the bushes like that, kind of beat them around a little bit, and make sure that you get that spray down deep inside the bush itself. And if you have some vegetation that kind of hangs over from the neighbor, if you think you can get away with it, then it doesn't hurt to squirt a little bit over there as well. The most important thing probably is to try to get on the undersides of the leaves. A good way of doing that is to use either a circular motion or a vertical up and down motion, not like this, where you just stick the thing out and shoot away. But more like this, just like this, we'll get excellent control of Aedes. This shows some results of a study that we did, and it shows about an average of 75% reduction of mosquitoes. These are mosquitoes being caught in a trap. 75% reduction after a week. And weeks it was a 60% reduction. This is the first time that we actually did this experiment. We had never done this before, so this is kind of a minimal expectation for what you would get. It greatly reduced the number of mosquito bites. This is mosquito bites is measured by a volunteer that literally stands out there in the afternoon in people's backyards and counts the number of mosquitoes that come up and bite them for 10 minutes. So there was a fairly significant reduction after 1 week, and that reduction continued over 6 weeks. One of the things I'm going to show you, I'm going to come back to this here in a minute, but it's very common that the reduction in the mosquito bites, and I'll mention here in just a minute. That's a very common result. But again, there's no effect on the culex mosquitoes. The culex are the principal vectors of West Nile virus, and at the time that we were doing this, That was the principal concern of people. And so I would caution PMPs and landscape professionals that were providing the service to not advertise it as something that would help protect homeowners from West Nile, because it doesn't. There was no difference really in mosquitoes, Culex mosquitoes that we would catch with and without the treatment. No effect whatsoever on them. This is from 2014, where we began working with demand with Archer. Archer is insect growth regulator. We've begun to experiment with tank mixes, different kinds of tank mixes in a variety of ways, some of which modify mosquito behavior. In this case, we're mixing demand with insect growth regulator, and this is those two treatments with compared to control. One of the things that's interesting is a very strong reduction of eggs and in the mosquitoes that we catch in gravids with demand and Archer, the gravid traps. Those gravid traps are primarily Culex, and so when we break this down by actual species, this is what we see with a very significant 61% versus 34% reduction in Culex. So this is a very promising result. It shows that across to some of these synthetic pyrethroid products like Archer, possibly some others, could have real promise for potentially increasing the spectrum of the mosquito control that you can get. Over 9 weeks, that protection continues. So here we have our controls, demand by itself, Archer by itself, 9 weeks after treatment, and there's a very good suppression going on here. It's not quite as good as it was very early on after treatment, but still it's at least 60% reduction relative to the controls. And again, demand plus Archer is performing better than demand by itself. Last year, this is 2015, again, we had significant suppression of mosquitoes for 2 months. This is just in CDC trap, all species combined. And the human landing rate counts, as I mentioned before, show an even greater suppression compared to the mosquito population itself. The reason for that, we believe, is that there's a sublethal effect of these synthetic pyrethroids that inhibit host finding or biting, and for that reason, every single year we've done these backyard tests now for human landing rate count. The number of bites that people get is reduced for a longer period of time than the actual number of mosquitoes. So that's good. Pointing out here the barrier treatment part of management responsibility to dump out water that are growing mosquitoes. A big responsibility is to avoid pruning and removing foliage. I can't tell you how many times I've gone in, treated a yard, and then all the foliage that we just treated is gone. They just decided to rip it all out, and so there goes your control method as well. Ideally, removing harborage sites prior to treatment. Gutter repair, I can't emphasize this enough. Sagging gutters, old water, they are invisible as far as the homeowner is concerned in terms of water source, but they will pump out thousands of mosquitoes a week if it's bad enough. So if you're out, see if there's any sagging and suggest or even offer a gutter repair service. That's a good way of cutting down the number of mosquitoes. Cold need to be given some expectations. They need to understand that we're going to suppress mosquitoes here, but we're not going to eliminate them. We're going to reduce some disease risk, but we're not going to eliminate it. Nor they need to they don't need. They don't want to over results from this type of treatment. That can rely on mosquito. These are some of the ones that are more prominent. I'm going to talk a little bit about these. effects, chemical trespass, resistance management. I've already mentioned the skill. Well, I could talk more about that. Like you have an individual who's spraying, I believe he was spraying demand here. A non-participating homeowner is out in her kiddie pool with her 2 young kids, and the technician is looking at me asking me what to do. You could go ahead and apply here, but you just have to be very careful, obviously, about wind. One of the main ways of avoiding chemical trespass is to keep the spray low on low windy days, and you keep that spray low by keeping that nozzle below the chin height. That's one of the main things that we've learned by putting water-sensitive paper out on neighboring properties and testing overspray. The insecticide layer and the 80s resting spikes, you can get into that with a low nozzle height, but the QLEX, you're just going to miss them. If you try to spray up into this area, then you're going to have a lot of chemical trespass. You'll get good control of those QLEX, but you're going to have a lot of chemical trespass. That seems to be around 8 to 10 feet. So that's about what you can do. And above you try. Sale resist methrin, which is, so it's really beginning to impact municipal mosquito control. But there's a great deal of variability between the species, particularly within the QLEX and the 80s groups. The residuals have relatively little problem right now. They're still on widespread scale, a high degree of susceptibility. But if the methrin resistance continues to develop, it's just a matter of time before that begins to creep into the residuals. So we need to begin doing things to manage resistance right now, or else we'll lose the products eventually. Now, it's worth noting that typical neighborhoods only have about 10% of the homes treated, so about 90% of the mosquitoes don't get exposed to the residual, but they pretty much all get exposed to the municipal mosquito control. So that the pressure for developing cross-resistance is there, even though a relatively low percentage of the homes are being treated. So we have to keep an eye on this. We want to try to, that's one of the motivations behind our looking into tank mixes, is to find products that have that can counteract developing resistance. It would be great to have products that we could that had different modes of action that we could rotate. I do know that new products are coming down the line that may offer that option at some point in the near future. This coming year is going to be a big year for backyard sprayers. I'm from the phone calls that I'm seeing, from the interest in this webinar, I'm sure that there's going to be a big increase in the demand for this kind of a service. It's likely to outstrip the availability or the capability of some providers to get around to everybody. You should understand that there's going to be a lot of spraying going on. Try to use a backyard spray, backyard control method as part of a more comprehensive program. I think Dr. Gallagher is going to talk about that in just a minute, at least one of them that's available. Consider printing a homeowner pamphlet on what people can do. Certainly CDC, Public Health Department sites will have lots of information that can be done. You might want to consider putting this into promotional literature. There are pamphlets. I know that some companies like Syngenta have pamphlets that you can just get. So consider doing something like that. It'd be a big help for the homeowners. Consider products that minimize treatment frequency. The fewer times you have to go back to a house, the more houses you can go to. So if you want to look at it that way, then it would probably be better to use a product that lasts for 2 months than one that lasts for 1 month. So think about that because there'll be, like I say, a big demand for services this year. And don't forget that you're part of an overall mosquito management effort. As I mentioned, This is going to be backyard perimeter applications. It's going to be an increasingly important part of an overall community mosquito management program, and it's and you're going to play a role in helping manage mosquito-borne disease in a large part of this United States. So I want to say thank you very much, and again, thank you for inviting me to participate in this webinar. I enjoyed it very much, and I'm going to turn this over to Dr. Gallagher. Thank you.
Thank you so much, Dr. Brown. And right before I introduce Dr. Gallagher, I want to just thank you for putting that all together. And for everybody on the call now, we're going to send a link out to both Dr. Brown and Dr. Gallagher's slides after this, so you'll have access to these right now. We're getting a lot of good questions. Attendance is holding strong, so I want to roll right into Dr. Gallagher's presentation. Dr. Nikki Gallagher serves as the Technical Services Manager for Syngenta Professional Pest Management in the Midwest and the Northeast. Dr. Gallagher has a strong background in urban entomology with more than 10 years of experience. She maintains responsibility for all phases of field testing and technical support within her region and coordinates numerous research programs with university researchers. Through her work at Syngenta, she continues her passion for protecting people's health, properties, and environments. She holds a bachelor's degree from Mount St. Joseph University as well as a master's and doctorate degrees from The Ohio State University. So with that, Dr. Gallagher, I will turn the microphone over to you.
Well, thank you, everyone. I want to thank GIE for the opportunity to present to you guys. And just following up from Dr. Brown, I'm going to cover more of the IPM perspective for mosquito control. So I'll mention some of the components of an IPM program for mosquitoes. And the second part, we'll be talking a little bit more about barrier applications, sort of building on what Dr. Brown has also mentioned, talk about a little bit about equipment and solutions to mosquito control in residential settings. So the main part for an effective residential mosquito management program, and keep in mind this is from the perspective of a residential setting, not from the public health perspective, so not from a municipality program. So the main components I see as being important would include education and knowledge, source reduction, and larval and adult control. And within those, it should include, physical, biological, and insecticides, are an important part of an IPM program. So let's start with education, and I also want to put homeowner responsibility in this too. Just like Dr. Brown mentioned, homeowners should have a responsibility in this too. It's really going to be an important partnership for this to be an effective program. And education and knowledge is an imperative foundation for this to be effective. The more you know about the mosquito biology, the more you are prepared to go in there and identify the weaknesses and take care of it and provide better control for your customers. And be able to provide that education to your homeowners too, so they know what to look for and what responsibilities that they have, that whether you can provide that for them or at least point them in the right direction of what they should be doing. Because if they don't help, they really could still be providing all of these breeding sites for mosquitoes, and the control efforts are going to be wasted. There's lots of sources of education out there, such as webinars today. So you have a foundation of mosquito biology and what's involved in control. But this can also be from a community or neighborhood level, whether you're providing the sources of information to your homeowners. At Syngenta, at the bottom corner on this slide here, we have these pamphlets that show the homeowners all different areas around a house that they should be investigating for potential breeding sites. Or you can go to the local health department. They have information. You can go to the CDC website, because we are the insect gurus. That's our specialty. But we don't know all there is to know about mosquito disease and transmission, and that's okay. But at the very least, if our customers have those questions, we can point them in the right direction. I already mentioned personal repellents, and I think that falls nicely under education. Again, if you're looking for repellents or your customers have questions on repellents, it's always good to suggest those that are EPA approved and that they're wearing them appropriately based on the concentration level of that product. So always read the label, and that they're wearing the one that is appropriate for their activity and the protection time that they're looking for. So other components of that IPM program, source reduction is going to be huge. And this is where we're getting rid of breeding sites for the immature stage of the mosquitoes. So this is the tumblers and the wrigglers that Dr. Brown was talking about. And this could be a great opportunity as you're walking around a house to actually point out to a homeowner, what a breeding site looks like and what the mosquito larvae and the tumblers look like too, because we might just take it for granted that they know what they look like. So pointing out to them and that this is what we're trying to get rid of. And even if they have kids, it can become a great game that they go around and they want to pour out containers that have water in. And then on a larger level, if there are issues with tire dumps or large areas on someone's property where there are depressions in the ground that can be physically fixed, that the soil can be flattened out or tires removed. These are the types of things that we're looking for because mosquitoes just love to breed in them. This is a long-term solution that is really cost-effective because when you think about it, it doesn't really cost much to just tip over a container of water. And the mosquito that we're mostly focused on, within the Aedes group, this is our backyard mosquito. And in our backyard, we have tons of areas where they like to breed. Whether it's a natural container, such as a tree hole, or a man-made container, such as a bird bath, a tire, or those dishes that we put underneath potted plants. All of these containers that can hold water for about a week are potential breeding sites for this mosquito. So those can be either physically removed or filled in with concrete, such as the tree hole. Now, if you have this situation in the bottom picture where it's buckets and all kinds of junk, where it's really out of control, hopefully that isn't a site that you're having to go into. Looks very complex. But that could be a site where maybe you have to call in your local mosquito authority and make a complaint, and maybe they can help direct what to do in that situation. Of course, when you're on a homeowner's property, just like Dr. Brown mentioned, you could be breeding Culex mosquitoes as well. Culex tend to like water that's more stagnant, that has more organic matter in it. But regardless of the container, regardless of the species, when it comes to the immature stage, we want to get rid of that as much as possible. With Culex, catch basins are a really excellent source for mosquitoes. You will find Aedes breeding in that too, but it does tend to be Culex is quite common because the water is really stagnant. If you have catch basins on personal property, they can be treated as well. But if they're on the streets, a lot of the time that's where your local mosquito control abatement program will probably be stepping in, and they could be treating that with a larvicide. So again, larvicides are an important part of an IPM program. If a source can't be removed or physically changed, you can treat it with a larvicide. These are just some examples. Microbial agents would include a BTI granule or a dunk. So that's a bacteria-based bait, Bacillus thuringiensis based products. They can be commercially available, so even your homeowners could purchase those. There are others that might not be available to them, other insect growth regulators. So those interfere with insect development. Typically are methoprene-based briquettes. A great thing about those is some of them can last 30 to 100, 150 days. They get a lot of residual activity out of those. But just make sure you check the regulations and label on those, because typically they're for professional applicators only. But they're great for places like gutters, other areas where you have standing water. If it's a sensitive area, that these IGRs or VCIs are a good fit to target the immature stages. There's also biological control methods. One of the big ones is mosquito fish. So if you have some enclosed bodies of water, like small ornamental ponds where you don't already have fish in there, if you already have fish in there, they're going to be taking care of any mosquitoes that are trying to breed in there. But if you don't, you can put those in. These mosquito fish are not native, so please check with your state that they are approved for use. They can't be released into natural bodies of water where they could become an invasive issue. Just to mention on other biological control options, these are ones that do not work. These include bats, dragonflies, and purple martins. Homeowners like to put them in their yards, and that's great, but they do not actually make an impact in the mosquito population. They can easily eat the mosquitoes, but they don't eat enough to make a dent in the population. So if your homeowners think they're making a green contribution to mosquito control, they're actually not. Okay, so of course, adulticides are the last part of that IPM program. So it's a very important part of the mosquito program, and Dr. Brown went into that. When you're out there treating, backpack misses really are ideal because they get under the leaves and into that dense vegetation. And I'm going to touch on that in a couple of slides. But when you're doing these adulticides, and especially because we're focusing on Aedes management, you want to use something that has a long-lasting residual because as the Aedes mosquitoes are resting on the underside of leaves, we want to make sure that there's enough products there that's going to last for approximately 60 days in these applications. Now, Syngenta has been involved in vector control, mosquito control since about the 1980s on a global level, and one of the things that we like to do is provide solutions to insect control. And the past couple of years, we've been working on a solution for residential mosquito control that takes into mind products that are going to do the job and do the job well, but also take into consideration the labor efforts of the PMP. And what we've put together is our two products for tank mix. And it's Demand CS, which is our pyrethroid, and Archer, which is our IGR. And with this protocol, you'll be treating once every 60 days to provide mosquito management for the homeowners. And again, this is part of an overall IPM program. So it comes as a pack together. So the Demand CS and the Archer comes in one multi-pack. And within that pack, you're able to treat approximately 40 treatments if every house has about a quarter-acre size property. So that's about $8.87 per treatment. And the purchase of this multi-pack falls into what we have built as our solution called the Secure Choice Mosquito Assurance Program. So treating on a less frequently schedule, just once every 60 days, if you follow these recommendations, your homeowner, complains and says, "Oh, please come back and reapply." If it's within that 60-day period, our assurance is that we'll provide that product back to you because it didn't hold up for 60 days. But we built this solution in mind with building the research behind it. And the IGR that we're including in this contains the active ingredient pyriproxyfen. It's a synthetic hormone that disrupts larval development. It does hold up to outdoor use. It's very photostable, so you're going to get that long-lasting residual, and it makes a great mix to add with a pyrethroid. So as you have your Demand CS and Archer and your tank mix, you can go through the backyard and get a pyrethroid and an IGR into those hard-to-reach areas. whether it's really dense vegetation that in itself could be providing breeding sites, you're going to reach out to those, and other areas in the backyard. Just keep in mind that this should not replace all of your source reduction or larviciding options. This is just a way to further increase the impact on the mosquitoes by using this tank mix. There's been a lot of research into pyrotoxicants. We know that when you force mosquitoes onto a treated surface with pyrotoxicants and then they go to lay their eggs, they can actually contaminate the water with pyrotoxicants, which then prevents the larvae from completing their development normally, and we reduce the number of adults in that particular area. So it's a very effective insect growth regulator. And of course, just to share a little bit of background on demand CS, it has, the characteristics that we would want out of a pyrethroid that we're going to be using for residential mosquito control. Those highlighted in the box in particular stand out to me. It's going to be microcapped to hold up. It has a higher activity, just naturally, lanthicide halofrin compared to other pyrethroids. It's going to hold up to environmental factors such as sun and also high pH, and it's going to give you that longer residual because we're looking for about 60 days for mosquito control. Just to point out that not all microcaps are the same. Demand CS uses IPM technology. It is unique within Syngenta. So this is the demand capsule here. All the other pictures over here are various other microcaps on the market. When you put them under pressure, under heat, demand CS capsules will hold up while other microcaps become damaged or completely collapse. And this is important if you want that 60-day residual. And also when you think about when you're doing mosquito applications, it's during the summertime when it's hot. Pyrethroids naturally are less active when it's hot. So you want to make sure that you have as much of that active ingredient available out there when pyrethroids are having a naturally harder time anyway. In the wintertime, your pyrethroids are much more naturally active. So you want to use something that's going to hold up and stay in the environment and be biologically available for the mosquitoes to pick up. So some of the work that's been done on this is, you're putting demand CS to the test under natural field conditions. And simply the question is, how long does demand CS last on a leaf? And this work was conducted by Dr. Sally Tolson and her graduate students at Virginia Tech. And they selected some landscaping plants that were common to Southwest Virginia. You can see some of the list here. So we had a rhododendron, an arborvitae, honeysuckle, a boxwood, and grass. And they treated those 5 plants, they treated them with a backpack mixture as a point of runoff, just like you would in somebody's backyard. We looked at 2 different rates of demand CS. And then those plants were left under natural environmental conditions, exposed to rainfall, sunlight, and so forth. And then once a week, we would take a leaf and evaluate them for their effectiveness against the Asian tiger mosquito, Aedes albopictus. So 10 mosquitoes would be put into one of these bioassays, and then you would monitor mortality. So basically, there was little difference between the plants. So we summarized the mortality for all of the plants. And this is the percent mortality, so one is 100% mortality. And the blue bars is our high rate for demand CS, which is what we recommend for the Secure Choice program. So even after 8 weeks, mosquitoes that were exposed for 24 hours to these leaves, we were still achieving 90% or greater percent mortality. So after 8 weeks, we know that it's holding up in this environment and still killing mosquitoes. Now, just to compare this to some research that's been published before, some work that's been conducted in Florida, this was a very similar study where they used bifenthrin. And they ended their study at 35 days. They looked at some similar plants and some other plants that were very different. And at 35 days, they had a range from 16 to 77% mortality. So that was an average of 33% mortality after 35 days. So just to show you the difference between your various plants, but also different active ingredients in different formulations. So with this particular study, we were able to show that Demantia did hold up, and in an environment where there was lots of rain. We actually had double the average rainfall during this 8-week period. So it is effective for long-lasting programs such as Secure Choice Mosquito Barrier Program. And if we're going to recommend, one application every 60 days, this fits in really nicely. Reducing labor for the PMP, but potentially also implications there for resistance management. If we're going to go out and do it less frequently, we're exposing the mosquitoes less frequently to those particular products. Just want to spend a few minutes just touching on product mixing, just some points from the field. Backpacks are ideal, whether it's a steel, there are other models out there, like the Solo is a brand, Mariano, I believe I'm pronouncing that correctly, is another model. When you're mixing in the tank itself, obviously you want to fill it half with water and then put your product in your other half of water and agitate appropriately. But just a tip, I think it's actually easier to use a service container, and you ensure that your product is uniformly mixed if you do it this way. If you put your product in the tank, sometimes a heavy concentration can run right into your solution feed tube. So the first area of a house that you treat is going to have a really high concentration, and the latter part that you treat might be mostly water. So one way to make sure that no mistakes happen is to do all your mixing in a service container and then put it into your backpack and go about your day in treating. And then you have a uniform mix, and everything will be uniformly treated. This is just a little bit of data from a study that was looking at how well various pieces of equipment disperse products onto foliage. We don't have time to get into the nitty-gritty of this study, but they used truck-mounted equipment and backpack equipment, and even those that have electrostatically charged heads. And the key points here are that you lose coverage the deeper your vegetation. In order to have effective coverage, you've got to have the appropriate equipment. Use the techniques like Dr. Brown mentioned, and droplet size and your product formulation is also important. The smaller your droplet size, and that's when you're talking about ULVs, is when the droplet size is going to go higher up and drift away. You want larger droplet sizes, and your typical backpack applicator does provide that. This graph is just showing you the percent spray coverage onto vegetation from different types of equipment into different depths of vegetation. So this at 1 meter, which is about 3 feet, this, the green arrow is pointing to the steel backpack. That provided the highest level of spray coverage, and that's from 3 feet away. So I think this is a good indicator that backpack applicators provide enough pressure and droplet size to really penetrate into that vegetation. And also when you're using it, it's easy. You can walk around the backyard, and just on demand you can target where you're applying that product. So again, the droplet size, the pressure, and the technique are really important for thorough dispersion of product onto that targeted area, because it's really different what we're doing in these backyards versus municipality type programs. Our technique is to be really targeted to where the mosquitoes are resting. Just following up, I think these are some small points that Dr. Brown mentioned. There are some landscaping that can help or hinder the situation. We don't recommend treating flowering plants or vegetable gardens. We're not going to find the mosquitoes in that area anyway. The mosquitoes are going to be in areas where it's dark and humid, in areas where you're going to get plants like this. In our neck of the woods, invasive honeysuckle is ideal for mosquitoes. It provides the darkness, the humidity, the protection. You want to make sure you get under the underside of those leaves, target them very thoroughly. As you move into other parts of the country, it might be similar vegetation. In Florida, you're going to have lots of these bromeliads, which are really dense, but at the same time can also provide breeding containers for mosquitoes. And again, there might be some situations where there are head scratches. You might have catch basins or storm drains on people's property. Just be aware of those, that there are ones that you can treat with a larvicide, or it might be something from a local mosquito control basis that they could step in and treat using a larvicide. Please be aware of the PPE of what product that you're using. Typically pants, long sleeve shirt, gloves, eye protection. A respirator is recommended. Typically not required, except if you live in California. Just want to point out that ear protection is also very good. Not required, but if you're going to be doing this all day, and if you've ever tried to use that type of missive, you know that they can be quite loud. So, if you listen to a lot of music when you're a kid, the hearing that we have left is kind of precious. So we want to make sure we take care of that. So just to summarize, MCS and Archer, are very effective in reducing mosquito populations on a localized basis. We're taking advantage of mosquito biology here. We're focusing on those resting sites of Aedes mosquitoes. They also have a short flight range, so they're staying mostly in people's backyards. Application and technique is important. You want to choose an insecticide that has a long-lasting residual, but it should be part of an overall program where we remove or treat the breeding sites and educate the public and our customers. And also be aware of what your state and local regulations are in terms of mosquito control. Match your customers to the service you're prepared to provide. Avoid claims of complete mosquito control or disease prevention. Make thorough inspections and advise customers of ways to reduce breeding sites and personal exposure. Follow the label. The label is the law. Your targeted treatment, make sure you're avoiding rain and drift. And keep in mind your personal protection, for yourself as well as your customers. With that, I thank you guys so much, and I'm going to pass that back over to Chuck.
Thank you so much, Dr. Gallagher, for that presentation on IPM and other control strategies. We're coming up on the tail end of the presentation time allotted, and we still have a lot of questions that rolled in. So I think what I'll do, Drs. Brown and Gallagher, is maybe submit those questions to you guys, and I could send out the answers to those, because I think a lot of folks would have similar questions. But one that popped up a lot is you talked a lot about treating sort of perimeter plants and shrubs and ornamentals, when they're not flowering. What's the best strategy for treating a property that does not have a lot of those ornamental plants, but still has homeowners or customers that are complaining of a mosquito problem? Is treating the turf an option, or how do you approach that kind of account?
Do you want to go first?
Go ahead, Nikki. I'll listen.
Okay. I was just going to say, there are going to be situations when you go onto a piece of property and it has, zero or just a few, bushes, trees, and it's mostly lawn. It could be a situation where you have to walk away as a PMP. That it's not going to be a great fit for mosquito control. There might be other things that you can suggest, that you try and find the source, where they're breeding, and try and reduce it that way. But the adulticide portion might not be an option, and you just have to have that conversation and say, this is what I can do, but I can't tell you that it's going to make as big an impact as you might like.
Sure. Sure. Dr. Brown, did you have anything to add to that?
Yeah, I was going to basically say the same thing. Not a given technique is going to be limited in terms of what it can do. It can't. One technique isn't going to control all problems, and if you don't have a perimeter to spray, then a perimeter application isn't going to work. And so, treating the turf is not going to help because there's not going to be any mosquitoes in there. Probably what is going on, and what our experience has been, when you have a mosquito problem in a wide open area, a house that has a wide open backyard, it's because of some other problem. It's some breeding site problem. It's not an adulticide. It's not a solution that can be solved with an adulticide. It's a solution that the solution is going to be found in larviciding or source reduction. And it's probably going to be in a cryptic location. It's going to be a crawl space sump pump or maybe one of the catch basins that Nikki was talking about, or possibly an abandoned or underused pool next door, or a dead boat in some neighbor's backyard. That's going to be the problem.
Mm-hmm. Mm-hmm. So it sounds like this kind of service really, maybe more than others, requires a fair bit of critical thinking and analysis.
It's a residual adulticide, so you have to have a surface for the residual to be put onto that will act on the adults. And if it's not there, then you can't use it.
One thing we didn't quite get into here, but a lot of people are asking about, is the effectiveness or usefulness of misting systems. I know some PCOs and LCOs install those and service those for customers. In your guys' experience, how effective are those in terms of an overall treatment program?
Well, they keep the mosquito population down, but from the perspective of pest management, from the perspective of the professional pest management, they're squirting insecticide in a way that I'm not a fan of them. They're just releasing insecticide at pre-programmed times, whether there's a pest there or not. I don't advocate those. I don't support those. I know there's people that install them, that make good money with them, and they are effective at controlling mosquitoes, but they are bad on a lot of non-targets, and I really worry about something like that being a cause for resistance. I don't like those personally. Most people in mosquito management are not happy with those.
I see. Nikki or Dr. Gallagher, in your experience, what have you seen with the misting systems?
I would say along the same lines as Dr. Brown. They might have an advantage depending on how or where you place them. Maybe next to a patio, that a place where you're going to be spending a lot of time. But they don't have the advantage of going out with a backpack applicator and being able to target all of the sites where the mosquitoes are. I think that's a big difference there in being able to really target the mosquitoes.
Mm-hmm. Mm-hmm. Well, we're coming up on the end here. So, Dr. Brown and Dr. Gallagher, I want to thank you both very much for taking the time to put those presentations together. I really appreciate it, and I think it was really helpful for all the attendees today.
Thank you very much for inviting us.
Thank you, everybody.
And everyone on the call here, look for an email shortly from us. There's a post-webinar survey that would be really helpful if you took. And next week, you'll get a link to the archived video and the slides from Drs. Gallagher and Brown. And I want to thank you on behalf of Lawn and Landscape Magazine and PCT Magazine for taking the time to attend. Good luck out there.